Hi everyone, I'm Yarden, Head of Community at StarTree, and really happy to see all of you here. This meeting will be recorded. We will share it afterwards with everyone who joined over our StarTree Slack. And in addition to it, you can Google it now. We have a StarTree YouTube channel and a new Pinot open source channel, so you can look for all of the meetup recordings there as well. And before we're moving it over to Barca, just to let you know, on April 3rd, we're going to have our first Apache Pinot contributor call. In this call, it's for people who are already contributing and for people who are looking into making the first contribution. So we'll go through how to look for an issue on GitHub, what is the PR and the release process, and it will be the speakers will be Shang Fu, which is a Apache Pinot PMC, and Avishak, that is a PMC committer. So it's going to be really interesting. The first meeting will be for everyone and also for those who want to get started with the contribution. The call will be for people who are actually contributing, like to keep it more focused and with value. The other thing, we have an real-time analytics summit. It's an online summit happening on May 14th. I'm going to share the links on the chat, not to bother you with that, but have a look. It should be super cool. And now heading it over to Barca Herman, our amazing developer advocate at StarTree, who will take it from here. Thank you, Barca.
Thank you, Yarden. Thanks for that. Important dates. And also the online summit, I believe, is free. So everybody should attend. We have speakers from all industry leaders, just amazing speakers. I am kind of bummed that I'm not meeting them in person, but I'll live. But I'll be there. So let me start with sharing my screen. Perfect. All right. So this is last year, end of the year, I spoke at an open source panel at IBM's Tech Exchange. And one of the things, people were talking about data and what's going on in the data space. And one of the things that I talked about was that, vector is the new JSON. So this is a topic that I am really deeply interested in. So hopefully you'll enjoy this session that I created. But before we get started, I have a quick poll. Where are you in your AI/data journey? So are you just starting, I'm here to learn, or actively evaluating technology options, using vector databases, using Apache Pinot with vector data and vector indexes, or use another vector technology? I'm very curious to hear. So please put that in the chat. I see some responses. Here to learn, a lot of learning, here to learn. Use vector databases such as, I don't know how to say that, Quadrant. Great vector database. Just starting, here to learn. Evaluating AI technologies for custom POCs. Okay, great. So you're hopefully you're in the right place. All right, so here's my agenda. The history of databases. I'll talk a little bit about structured versus unstructured, a little bit about rise of JSON, talk about vectors, and we'll do oh, typo, vector demo, not Vector demo. Yay. And then we'll talk about the future of data. I promise that the history slide is just one slide, so bear with me. It's not like I'm not going to go into a history call here. So I can easily share the deck. I'm happy to share the deck. So this is where we are. In the 60s is where the hierarchical and network databases, example IBM's IMS, started. In the 70s was the seminal paper by Edgar Codd on relational model. And there was a paper in the 2000s on JSON, and then JSON started showing up in databases. And of course, in the 20s, and it really started with 2010s is when AI, the next generation started, but we weren't doing vectors and databases yet. So I'm asserting that LLMs came along in 20s, and that's what popularized. And yes, I do know that vector and databases were available before the 20s, but really this is where it became popular. Okay. So of course, we have the dominance of relational database management systems such as Oracle, MySQL, Postgres, of course, SQL Server by Microsoft, IBM's SQL language, all this stuff was going on. Structured query language SQL started at IBM, by the way. And here's some of the strengths, but the limitations, of course, were the rigidity and there were scalability challenges. And who remembers, I mean, I'm dating myself here, but who remembers XML and XML-based schemas? That was one tangent that we were going on for APIs, WSDLs, and all that stuff. Anybody remember that?
Yeah, we used to do.
Yeah, and that was yeah, there you go. So that was a tangent, and it was really like the starting of a solution because we needed a solution for expanding schema, creating, sharing schemas, and taking into account version schemas and things like that. But of course, uh, JSON came along and all that just disappeared because JSON's so much easier. So let's talk a little bit about structured versus unstructured data. So structured is organized. Obviously, relational databases are structured. Unstructured is no predefined format. So text, images, audio. And then, of course, we have the XML and JSON, which is semi-structured. So it's a hybrid. You can call it unstructured, but it's really semi-structured because it does have labels, we know data types and all that kind of stuff. So semi-structured data, JSON, the explosion of unstructured data with the internet is the reason why we had to rethink the whole, moving schemas, support for JSON and whatnot. So of course, there was a data explosion in 2000s, Web 1, Web 2.0, social media, IoT, all this stuff is happening. So this term called big data was born. Back when, yeah, Aaron says, I spent a ton of time on XML with PeopleSoft and Oracle. Yep. And Dave says Altova helped. Yeah. So those were the days, right? We could say that people now have it easy, but there are still complicated new tech showing up in the space. So we had this concept of big data, which I mean, the data was big. The first IMS was created for air traffic, so it was already big. But we were using mainframes back then, or even Sun Microsystem based large computers that had bigger capability. But then people started putting databases on desktops. So obviously there was need for flexibility and scalability. And I would add agility. So what happened was as a response to this, yeah, and yes, mainframes are still available. They're still selling like hotcakes. People don't realize this. But so emergence of NoSQL, MongoDB, Cassandra, et cetera, happened in 2000. The funny thing is people think that NoSQL is new, but actually IMS was NoSQL before SQL, right? It was a document database. It's just that after that, we started moving towards the structured approach. And even in the early NoSQL databases, they were document databases, but they had records. So they were kind of structured. Now we have schema-less design for documents, right? key value document, graph type of things. So it went from how do you map images and documents rather than records. The records are kind of structured, but NoSQL databases were able to, store and quickly retrieve things like images. Aaron says, I work for a new payment system that is mainframe based and is still the standard. We forklift the data to all the new cool data patterns. That's funny. Yeah. ETL will never die. It's funny. Anyway, so yeah, 2001, JavaScript open notation created by Douglas Crockford. It's super lightweight. Everybody had amnesia about XML as soon as JSON showed up. And it was great because you could have, partial schema, semi-structured information. You could still key on the certain things that were required, and you could add, attributes, stuff dynamically, and it didn't break the pattern. And then, the next thing that happens is that databases start now implementing JSON support. I still remember the first time I started using in my query, JSON path type things to start looking for nested data in a JSON object in a database. So obviously, MongoDB adopted JSON immediately, right away. And then relational DBs also started supporting JSON. A great example is Postgres. So it has a lot of flexibility. You could query dynamic data without schema changes, right? So if let's say that you're a e-commerce store and you are storing widgets, and the widgets have, one widget has 10 attributes, another one has 50, not a big deal. You don't have to define an array. You can create all these things dynamically and you can use it. So just a side note here, Apache Pinot, of course, supports JSON. JSON is they support a very complicated index that flattens the JSON, so it makes JSON queries super fast and keeps their real-time nature as consuming and querying, and also for roll-ups and aggregation, etc. So JSON change databases bridged between structured and unstructured, enable rapid development, and created scale. So a lot of the problems that we were noticing were solved by JSON. So I'm not going to go too much into JSON. JSON is an amazing data type. We use it every day. Apache Pinot uses it to describe schema and table structures and many other things. If you're in this space, you use JSON. So then what happened? Now, we have AI, and suddenly we have new data needs. So I remember I used to work for AutoNation way back in the day, and we had, of course, AutoNation is a global, nationwide car dealer stuff. So they had literally like millions of cars. And I remember the cars had images related to it. And this is before vector indexes, AI was a thing, or AI has been a thing for a long time, but it wasn't as ubiquitous as it is today. So the only way for tagging the images was creating metadata. And so we had this, great, like a lot of metadata so that images were searchable by the web. And, you had to tag it correctly. You had to have the right color, name, model, year it was made, all, what kind of interior. So the metadata was massive for every image that we were processing. And we were getting, hundreds of images per vehicle. So it was its own thing. Of course, now we don't do that. We have image search. So image search can tell what car, something as simple as is this car a sedan or a coupe? Um, you the image search can solve for it. You don't need to tag it by saying what body type it is. But back in the day, I remember having to do that manually for a lot of stuff. A lot of people don't realize reCAPTCHA is also used for labeling, data labeling, right? Anyway, so now we have AI and we have new data needs. Yeah, Aaron says Mongo was a bomb when it rolled out JSON support 15 years ago. We used a ton of it until we moved to Postgres at scale. Yeah, absolutely. Mongo was an early adopter of JSON, and I think that was one of the reasons why it blew up. But that's opinion. All right, so what are vectors? So vectors, it's a series of numbers. By the way, I lifted this image from Pinecone. They're a vector database company. So it's arrays of numbers representing data in a high dimensional space. It's generated via embeddings. So there are algorithms that generate it and then capture semantic meanings, such as king is adjacent to queen. So let's consider three words, right? King, queen, and man. You can see that king and man have a relationship, which is all king are men. King, queen have a different kind of relationship. So they have similarity because they're both royal. So there's a different type of similarity between those two. But a queen and man are probably not as closely related as a king and queen or king and man. So this is the kind of stuff that is the semantic meaning, the meaning search between king and queen. A good way of thinking about it is that this is not a bag of words search. So I remember when Google search engine first rolled out, and I was so excited because it had fuzzy searches. So if I fat fingered my search, it would figure out what word I was trying to type and auto find it. And that was such a big step, and it was so great. Because before that, the words had to be typed correctly. So it's funny. Now we have semantic search. When we are, and I don't know about you, but I'm not using Google, like the Google search anymore. We're using AI for searching. And the AI figures out what you want and gives you a small explanation of what the answer to your question, plus links and whatnot. So we're used to now just, whether you're using, or whatever you're using, gathering data by talking to the AI, which is finding the meanings, not searching for the words, but the meanings. So that's what this means. Enable similarity search and clustering. So the vector is representation of each word into a numeric string, and then the numeric strings are compared with each other to see how close they are within a context. So we'll talk about it a little bit. So this diagram kind of shows you that you put in a content into an embedding. The vector embedding show up in a vector database where you put them, there's distances are calculated based on the query string. So when the application queries it, it's looking for similarity, not specific words. All right, so let's talk about vector databases. So I mentioned Pinecone. Of course, Pinecone is a vector database, so is VV8 and Milvus. There are many more. And what they do is so the diagram kind of shows this, is that, we have these are the different types of databases that we have. We have this key value pair, which is what the document databases essentially are. That's why they're very fast. Or you could just have a key value pair databases like Redis, Cache, or something like that. Then you have the graph databases, which is you have nodes and edges, and nodes are the data, edges define the relationship. And then you have vector databases, and vector databases are in a three-dimensional actually it's multidimensional. We see represented as three-dimensional, but it's multidimensional spaces. And what we're doing is we're looking for similarities between data. And if you don't fully understand it, that's fine. I'm going to do a demo that kind of goes into a little bit of that. All right, so why are vector necessary for AI? So AI models rely on embeddings for input output. So when you are talking to ChatGPT, for instance, you're saying, hey, find me a diagram or whatever, a write-up on vector databases. It's actually going to convert everything that you're saying. It goes through some filters, like it'll drop all the us and thes and whatnot. Then it'll create a list of the words, and then it'll convert those to embeddings. And then once the embeddings happen, it'll go to its models to find similarity and then come back. And then the LLM will do a lot more. And I do have a slide on LLMs. But behind the scenes, it's actually using vectors for searching things. So for example, the suggestions for Google Image. By the way, I used Google Slides today, and all these images are created using AI. So, well, not all of them. Some of them are architectural diagrams, but those I attribute where I used it from somewhere else. Mahesh says, how is the list array aspect of the vector related to the vector DB 3D storage? So different databases implement it in different ways, but there are some standard set for creating vector arrays. And basically, it's a string of numbers. If you have, I'll give you a very simple, I like simplicities to understand things. If I give you a simple example, let's say that I want to map alphabet. I can always assign a number to each alphabet, and then each word is like an array of the items in the word. Now, when you talk about the high dimensionality, that's when the complexity comes in. And one of the things that I ask is, what is the difference between a vector and an embedding? A vector can be done by humans. Embeddings takes computers. Basically, because they're so complicated that they're hard to explain. But the vector databases store data in n-dimension arrays, and the dimensionality defines how it's 3D, right? It's complicated. So I don't know the math on it. I wish I did, but I don't know, Mahesh, if that answers your question. And I'll show you what the vector data looks like in Apache Pinot in a minute. So maybe that'll help. All right, so we talked about, yes, we talked about a little bit about similarity search, right? So JSON was, hey, I have some semi-structured data and I want to look for everything that has this attribute. So what you're doing is you're going down this path and you're looking for the attribute list and looking for a particular string. So you're doing JSON parse, JSON path kind of query, right? Similarity search in vector is very different. So to take that man, king, queen kind of example, which is it's a very rudimentary example, but I like using simplicity to explain complex ideas because that's how I learn. The goal is to find the closest items in a vector space. So let's say that I have a database that has only 2 rows. And let's say that it's a database of countries. And I want to say, hey, I want to find the closest country from, let's say, United States. And the other country in the database happens to be Mali in Africa. Well, guess what? It's going to find Mali because that's the closest thing in the database. If you have a database of millions of records and you say, hey, what's the closest airport to Fort Lauderdale? then it'll look up and it'll do this complex nearness search. So the data matters. Let's talk about some algorithms. So Apache Pinot, as well as many others, including Pinecone, use this thing called hierarchical navigable small worlds, which is an algorithm that is in this diagram. So how does that work? There are two concepts here. One is actually borrowed from the graph database, and you have nodes, which is your data, and then it's graphed because what the graph says is that, hey, this is my nearest neighbor for this context. So let me say, let's take that silly example of man, king, and queen. If I'm looking for things that are closest to a king in the context of royalty, it'll be queen. If I'm looking for the things that are closest to a king in gender, it'll be man, right? And so that's the kind of graphing that needs to happen. And then the small world, what it does is that it divides the sets of data. So the easiest way would be you go to a node, random node, and you start searching all the closest things till you find something that's closest to the query, which is very, very complicated and very time consuming. Its efficiency is O of n. And so the bigger the data gets, the slower it becomes. The hierarchical navigable small worlds model breaks it down into different levels, and each level has more data. So instead of starting in a random space, what you do is you start at the top level, which has the least amount of data, to find which area your data is in. Then you go a level deeper, and then it has a few more to refine the data. It's kind of like saying, analogy that I'll use, which is again simplistic, is in order to find my house, you first have to find United States. You go to United States. Then you say, okay, it's in the state of Florida. And then you start looking in the state of Florida. Once you're in Florida, you can start looking at Fort Lauderdale, and then you can find my neighborhood. So that's the process. And of course, Peter is sharing some great links on how this works. So if you're interested in learning more. But there's a lot of literature out there, and a lot of a lot of people implement HNSW. So that's the similarity search, vector search part. Let's now talk about large language models. And you're seeing tools all over the place now that give you the ability to query your data using language. Find me something to cook, and these are the ingredients I have. Wouldn't that be great if you could ask your database a question and then they answered? And again, this idea is large language models help us convert what we're asking for into vectors, and then the vector does the similarity search. It comes back to LLMs, it transforms that back to English or whatever language you're using, and you get an answer that's readable. And all this is happening behind the scenes, and this is where we're headed, right? In order to support that, though, we need vector. So again, if you went through the life cycle of JSON into data, you realize first it was there just to kind of simplify schemas, be able to add new things into the database, and then boom, it changed everything. And it's my assertion that this is what's happening now with vectors. So this is my handiwork, this data, this diagram that I created. It's not the best. However, it kind of tells you what's going on. So there's a ton of data. You convert it to embeddings, you put it in a database. Now a person comes in and asks a simple question in plain text. The LLM is used to augment that into something that actually makes sense and then to the database or using vectors, it goes into the database and comes back and responds. And then again, the LLM is used to, you can either, return the data set, or you can use LLM to translate that data set into something that's human readable. And that depends on the application here. So we're just in this realm of what's going on with vector data. Thank you, Aaron. Okay, so some real world examples. E-commerce product recommendations used to be based on what people have bought. People who bought this also bought something else and blah, blah, blah. Of course, now Amazon uses Q. I don't know if you've used it. It's pretty cool. And what they're doing is they're using all their recommendation based on AI. Also, you'll notice that all the searches now have an AI component built into it. Personalization of feeds, YouTube, TikTok use AI, chatbots, knowledge bases. Everybody's favorite chatbot, ChatGPT, uses this. So this is happening. And one of the things, if you think that this world of data does not require real-time databases, which is what Apache Pinot is, just notice that OpenAI bought, Peter, what was the company? Rockset, which is a real-time, database. And why would they do that? Because we need answers, we need vector searches and comparisons, and we need them now because we live in this impatient economy. So is vector the new JSON? I'll let you decide, but I do think that JSON brought flexibility and semi-structured data to databases. Vectors is bringing the power of AI-driven unstructured data. It's not a replacement, but it is a paradigm shift, just like JSON was so many years ago. And it supports hybrid systems, of course, JSON and vectors. Apache Pinot supports JSON plus vectors. So does, ClickHouse. So does Postgres, and a lot of the database. So you'll start noticing that instead of replacing it, this is just an addition to what's going on, and you'll see that vector becomes ubiquitous in the data space. So, okay, oh, this is not the right demo. So let's, the URL is bad, but I'll share the URL with it. So let's do a demo. This is the demo that I am working on. So this is the vector demo. And let me bring up the README. And this is available right now. If you go to StarTree Data Examples, which is a open source repo of StarTree, it's here. In order to save time, what I did was I built and deployed it already. So this is what Apache Pinot looks like. So this is the cluster view of Apache Pinot. You can see that it has one controller, one broker, one server, one minion running. There's one tenant, and it has 10 tables. So I'm going to go to the query console, and you'll see all these tables. And let's do something simple. So let's do this table, which is Fine Foods Reviews. So I'm just running this simple query, select star from Fine Food Reviews, and it's going to give you this list. It is a small list. And what you'll see, so this is the summary. This is the entire text of what the review was. And then is the good stuff. This, my friends, is the embedding. So you'll see that it's a very large list of just numbers. And that's what it looks like. Extremely unexciting, not very exciting at all. However, what we can do is, again, I'm going to move. And there is this SQL query that I can run. So the question is, I'm doing a similarity search. So let's cut and paste this, and you'll see how ugly this is. Give me something that's similar to. And here we go. It's actually finding some tomato soups. The embedding is something to do with tomato soup. So here are the reviews related to tomato soups. But you'll notice that the embedding, the query itself is pretty ugly because it's actually saying, hey, find me things that are similar to this embedding. And this embedding is quite ugly. So, um, so obviously this is great for behind the scenes kind of thing, but we don't want to use this as a way to, as an app because it's not very user friendly. But I just wanted to show you that this Fine Foods review, and let's take a look at what it is. So actually what I'm going to do is go here, go to tables, and look at the schema. And so here's the schema, right? So this is what it looks like. It's got some table stuff, table configuration, and field list. So here's the embedding. So this is the data type that is supporting what we are seeing. The encoding is raw, and it has a vector index. Now, vector index is the thing that's doing all the magic for the querying and for the comparison. And if you go back to the query console, hey, somebody's saying something. Yeah. So great question, Mahesh. And so that's next. But I just wanted to give you the behind the scenes kind of deal of what is happening. So what we're going to do is I'm going to go to my Visual Studio. Yay. Here, what we've done is this is a different app that I'm running. And what I've done is this app actually does many things. So this is the RAG. Again, if you go to the examples repo that I shared, there's a RAG that folder that actually shows you what is happening. So in this, what we're doing is we are going to we're going to run a process, which is this thing called, so we'll deploy Apache Pinot first, of course. Then what we're doing is we're running this loader thing, and the loader thing will go through a URL and collect all the pages, convert it to embeddings, and load it in the database. So you want to do it programmatically. You don't want to type any of that stuff out, right? Because remember I said vectors, humans can create vectors, embeddings requires programming. So they're complicated. You don't want to run that. So this actually will go ahead and walk through. So what we've done is we ran the loader against dev.startree.ai docs. So all our docs are in this. Actually, not all, because I'm running this locally and I don't want my computer to blow up. So if I go here and go to documentation, this is all the documentations. And again, you'll see that there's stuff and then there's embeddings. So this was done programmatically. This is the loader part of things. Then you have the question part of things. So we have another Python script called question. So if I run that, what it'll do is it'll say, hey, search query. So what I can say is, how do we load JSON data into Pinot? And it'll go ahead and create an answer for you and then also give you the references. So it'll give you the links that were used to create that answer. And basically what's happening in this question.py, it's a simple thing. What it's doing is it's taking my question using an LLM, which is OpenAI, converting it to vector embedding and doing executing a similarity search behind the scenes. And then when it comes back, it'll give you this list of answers. So that's what's happening. That's what needs to happen. Apache Pinot is a piece of the cog. It's not the whole solution. Obviously, we need apps to use the data. But in order for all that, we need to first start with something that can support all this stuff. So much for the demo. Thank you, Aaron. Okay. So let me go back to my demo and let me fix this and say examples. And I'll share this deck with everyone, so not to worry. But so that was a demo, guys. What do you think? Any questions still? Because this is the point where if you're still not clear, then I'm here to help. So I could not, I'll be honest with you, because these are models that are inherent within OpenAI. So if you go to the OpenAI API, I have my the key to use OpenAI. And what I do is I say, hey, what are the lists of the models? And the models are described for purpose. So if you go to the OpenAI list of models that they have deployed, they'll tell you what model is recommended for what kind of lookup. So so can I describe it off the top of my head? I don't remember why I picked that, but it works. So, yeah. Well, thank you, Mahesh, for your kind words, and Aaron. Yeah, and I'm using OpenAI in this. You don't have to. You can use whatever LLM model you like. The only thing is that you want to encode and decode using the same model, obviously for obvious reasons. And also, when you're encoding, there are some parameters like how many dimensions and things like that. When you're asking the question, you want to keep the same parameters. But all this is like, as computer science folks, that's some obvious stuff. And feel free to reach out to me. So this is my LinkedIn, connect with me for sure. Here's our website, StarTree.ai is the main website. Dev.startree.ai has the documentation and a lot of other stuff. And the QR code is, what we're doing is for people who attended this meetup, if you scan this and fill out, we do random draws for t-shirts. So you'll end up getting a t-shirt for being here. So we do a giveaway for every meetup, which is amazing. Of course, when you're on dev.startree.ai, there are links to join our community, which is Slack-based. And a lot of us are on the Slack most of the day. So feel free to reach out there if you have questions. And we are working on additional, vector-based apps and demos and things like that. So if you have suggestions on what to do, also very interested and open. I'm just a data geek, so I'm not exactly, I don't come up with the best demo scenarios all the time. So I'm here, I'm happy to hear from everyone. Okay, so that's a great question. Vector searches are faster because, numeric comparisons are faster. It depends on what kind of RDBMS searches, right? So if you are comparing just a word array to another word array, then obviously it'll be a little slower. The numeric comparisons are faster. And most of the vector support databases, including Apache Pinot, have optimized for vector searches. So Apache Pinot has a vector index, which is optimized for comparison. And if you know anything about Apache Pinot, it's amazingly fast. And there's a lot more technology that goes behind it. One of them is that it's distributed data, distributed processing, as well as high performance index. So it's fast to begin with. And so that also helps with it. But a simple, relational database relies on relationships, whereas this is a whole paradigm shift. So you need to support similarity search in order to make it faster, right? Thank you, Carlos. Sharon says, what is the best way to learn more about Apache Pinot? So we do have a repo called Learn, StarTree Data Learn. And we also have a YouTube series of fundamentals like Apache Pinot 101 and Apache Pinot 202. These are playlists that you can go to. So great question. And if you follow that, it's a great place to start. And if you get stuck, just reach out on Slack. Raheem says, good presentation. Great. Yeah, taste of Pinot is always a good thing on the weekends. Thank you all.